Hello guys, welcome to my YouTube channel. So today we are going to see clustering problem in machine learning. So clustering problem is something like we are using the unsupervised learning. So clustering, which means like we have the data set which contains some data points. Let me show you in this demo like how we can do that. Let me first give you the types of clustering. So first of all, we have two types of clustering, which is hierarchical clustering, and second one is a partition clustering. Let me put the name here as well. So you can see we have two types: hierarchical clustering and partition clustering. In hierarchical clustering, there are some algorithms which is called like let me put here, or let me use that sklearn and show you how we can use or how we can pronounce that. Then we can use the clustering, then we can use this one, we can use this algorithm which is called agglomerative clustering. I'm not sure how I pronounce this name, but you can see agglomerative clustering. This is the type of clustering which are present we perform in the hierarchy clustering. Means this is the type of algorithm we use in the hierarchy clustering. And for the partition clustering, we are using the another algorithm which is called k-means. So we can use sklearn, the same class which contain the k-means method, which is like k-means. You can see that I have sklearn package which contain cluster class, and inside that there is subclass, or inside that there is subclass which is called the k-means. So now you can see that these are the two methods. One method is for the hierarchy clustering, this is the agglomerative, and another method which is called the k-means, which is used for the partition clustering. So today we have some data set. So we have the data of the mean distinct day and mean over speed percentage. So now you can see that there is also the ID column, but we don't need ID column, so we use the drop method to drop this column. We use the labels. I just click the shift plus tab to see what the label look like. Then I will give the here ID, and I will use the what is the method, we can say index or axis is equal to 1. So here x is equal to 1, which means delete the column and in place equal to true. So this is the three parameter which we need to give. Now you can see that if I use the df.head, it contain only two column. So now we are performing the clustering. So before that, let's draw this, or let's use the scatter plot and draw these data points on the graph. So you can observe that why we are using the clustering. So PLT is for the matplotlib. I already imported this package. Then we use the scatter plot. When df dot, I use the mean for the x-axis, and df dot, I use the mean over speed for the y-axis, and PLT dot show, which print for the showing the algorithm. Now you can see that I have the different groups, right? This one is one of the group, this is the another group, this scatter plot, this the data points, but which contain large distance between each of them has one of the group, and this is there is the four group. We can say we can observe using the human eye and predict that there are the four group which are present in my data class. But we need to figure out that, okay, we need to provide the labels to data class. So in that way, supervised learning, which means labels are not present and you are predicting something, or you are assigning or grouping something based on the labels. So let me perform the k-means clustering. So what k-means clustering will do, we'll select any point and just choose the random 5 point near to this one point, and if this point if that random 5 point got, which will assign the same class to those points. So there are some explanation of k-means clustering. This is a short explanation that I given to you, but you can also go through the YouTube and the other videos of mine and check that what the k-means clustering in the details. So now you can see that I have just print the data point in the using the scatter plot. Now let me do the k-means clustering. Before that I need to check that is any null value present on my data or not. So for doing that we can check df is na, then we are using sum method. So it will print that. You can see that there is the 0 null values present in my data class. So we are good to for the algorithm part. Now we already imported that the k-mean class. Now let's use it. So we can use k-mean underscore cluster equal to, we can use this one, and it has some parameter which is like number of cluster. Means in the human eye how many how many data points or how many class you can see. I can see the 4 to 5 class, but maybe sometimes the human eyes are wrong or class are not actually predictable using the human eye. There are there are other methods as well to give you that how many clusters you are use or how many groups you can use for the clusterings. So I will discuss this after in the end of this video, but right now I am just using the random number which is called 3. So I just initialize my k-means. So let me rerun this. It just hang up. So let me refresh this. Sometimes because of the data is little bit of high size, so it will like just hanging up. So let me use this one. Let me see like what happened. Okay, actually kernel is restarting, so that's why it's giving me the error. So it restarted successfully. Now you can see that my k-means clustering. Let me run all the cells. You can see that I am running all the cells, which will print my everything which are present. It will take some time. So here is we are just putting the k-means algorithm and initialization the k-means method and with the 3 clusters. Now let's me meanwhile do the k-means cluster dot fit method and passing the values like df for, because of the this is the training data set, right? There is the no labels or no output present in unsupervised learning. So that's why I'm just passing it the df, which is my training data set. Based on that, this will calculate something for me and give me the output. Let me see where it's failing. Okay, this is failing because of this. Let me rerun this all again. Now you can see that everything is run. Now my graph is showing there is no null values. My k-means is also initialized and it's also fit with my training data set. Now you can see that I use the 3 classes, which means that this will predict the 3 classes from this data. So let me use the k-mean cluster dot labels. So this has the some labels, which means that how many classes we need to predict. So labels, which means for these data points it assigning the labels to each and every classes. So based on that there are some data points. Let me use the dot unique method to see like how many unique values which are present in my data class. After that you will be see, okay, there are some errors. So let me use the numpy dot unique, then I am just using the same labels because it's a numpy array actually, so that's why it's not working with the unique classes. So you can see there are the 3 labels which are present, means in data set it's just giving me the 3 labels. Now my k-means initialization successfully, training is also done successfully. Now let's see other values, which means that k-mean dot we can center of the cluster. So these are the 3 points, which means that center of the cluster, which means that there are the 3 points present in my this data set where the center of that label belong to those columns. Means for the first one, center is 59, 58 and 8, which means that where is the 58 and 8. You can see here is my center of the first class where all near a data point which are connected to this. Now I have like the second data point which has the 180, which means that here is the class actually which are present, and on my y-axis there is 18. So here, so this is my second group. based on that we can predict that. And third group is like 42 8, which means that where is the 42 in on the x-axis, there is the 42 which means present here, and 8 is which is present here or something like that. Here is my third class. So this is the three classes which predicted by the unsupervised learning, but this is not the user friendly output, or it's not a predicted output via human eye. So that's why I'm just using some advanced CSNS libraries to print this output in the good way, or in the colored way, so you can easily observe those things. So here is my, you can say here is my something like, I'm just copy pasting this thing. This is the block of code which will print the group of data. So now in the x, right, what is my x? So let me use this. So here we can see that I have the two things like, so let me use this one. So now if I just need to replace this thing. Here is my this one, then I will go these things, right? So I doesn't need any ilog function here because this is the different one. So let me use this one, let me use this one. I doesn't require this ilog function anymore. So this is also not required, this is also not required, and use, which means that k means dot labeling, which means what we predicted. So this is my new data frame. So now let me use this one, like here I'm just using x for mean distance, and for y for mean distance day, and x for mean distance speed. Sorry, here is the x for mean distance day and y for mean distance speed predict, and for the y we are using the same, or for u we are using the same. So now let me run these things first. So you can see that this is actually my divided the three class, which means that this is predicted something. This is convert my this complete data set in one class, which is called the one class. This blue is the another class which is called the 0, and the orange is also one of the class which is called 2. So now you can see that. Before that, let me print that new data frame here so you can observe this. So now you can see that I have the input of the two things like mean distance day, mean over speed prep. So there are some data points which look like this. This is the one class, right? This is the look like one class which are present, but I want to classify those data or assign the label based on the groups. So they have some different characteristics. You can see that in my this data class there are some gap between this. They are the empty gap, which means that this is the higher value of the x have belong to the different class, and lower values of x belong to the different class. So now, so what I will do, I just input these two things to my k nearest neighbor algorithm, and based on that it will predict something. It will predict the data classes. I just print the data classes in the graphical way. So which prediction will be like this: my graphical or my algorithm predict that this is the one data class, white color, blue color is one data class, and orange color is one data class, which means that let's take one example. White color is the x data class, blue color is the y data class, and z is the a data class or b data class. We can take any name. So these are the three labeled data class. We will fragmented those things, and based on that we predicted something. So now this is the labeled data. So now you can pass this data to any supervised learning algorithm, and based on that you can train algorithm. So this is the main core of the unsupervised learning. So that's what I want to explain it to you, that this is the data class. So but let me do one thing. Let me use here number of cluster equal to 4. Now I will run all the things again. Now you can see that there are 4 data class, which means that the orange data class, this one is orange data class, faint orange another data class, blue another data class, and faint blue is another data class. There are the 4 data class, which means that actually in my model there are many data class present. Based on that what the value of k I use, based on that it will predict something. But now there is the question in the mind, right? Which value of the k we should use for that. To using the good value of k, you can use some function or some error function which is called the inertia. So now you can see that my inertia is 719603, means 77 lakh 19,603. This is my inertia for the fourth group. Now I just use here 5 and I just retrain my algorithm, right? And now I just, this is my older one, right? 7169. I just copy paste these things, and if I hit enter, you can see that now if I use the 5 data classes, the inertia will decreases. So you just have to make sure that there is some point where you have less inertia. This is your value of k. So you just have to check for all the values like 5, 6, 7, 8, 9, 10, and where you found that okay, your inertia value is not changing that much after changing or increasing the number, then you can use that your point of the k, or that the value of k you can use in this algorithm. So this is the method in the way that you can take the value of k which is required for you. So in that way I will explain you how can implement the k means algorithm in unsupervised learning. So that's pretty much from my side. I hope this will explain you the concept behind that k means, and explain you complete guide of the k means, how we can implement those things, and where to implement k means, and where to implement this unsupervised learning. So yeah, that's pretty much from my side. If you like those video, please subscribe to my YouTube channel. Thank you.